Hello students, in this video we'll see an example of computing the variance of a random variable from its CDF. Let's suppose that x is a random variable with CDF f capital of x defined piecewise by the following function. It is 0 if x is less than 0. It's 1/4 plus x if x is equal to 0 but less than 1/4. It's equal to 1/2 if x is between 1/4 and 1/2. It's x if x is between 1/2 and 1. And it's 1 if x is bigger than or equal to 1. So I have my piecewise defined CDF. So let's plot the graph of this and see what it looks like. So if we plot the graph of the CDF, here's x, here's f of x, here's 0. So the CDF is always equal to 0 up to this point. Then all of a sudden it jumps up to this line. Here's 1/4. And it will go all the way from 1/4, and so there's an open hole over here. So it will go from 1/4 all the way up to this point 1/2, and then it will remain at 1/2 all the way to 1/2, at which point it will become x all the way up to the value 1. And then it will stay 1 forever after that. So this is the graph of our CDF. One thing we can note from here is we have this jump discontinuity over here. So what does this jump discontinuity tell us? So the jump at x equals 0 implies that the probability that x is equal to 0 itself is equal to 1/4. So 1/4 of the time, x is identically equal to 0. Then the rest of the time, it's a continuous random variable. So let's compute the variance. So the first thing we'll do is compute the expected value. So how do we compute the expected value? So the expected value is found by computing the derivative of this. So what will the derivative be? So my PDF, f of x, will be what? It'll be 0 over here. Then the slope of the line between 0 and 1/4 is equal to 1. So then it'll be 1 when x is between 0 and 1/4. Then it'll be flat between 1/4 and 1/2. Then it'll be 1 again between 1/2 and 1. And remember that this is the part of the continuous random variable, and there will be a jump at 0. So that will account for the other 1/4 probability. Since if we look at this, it's not defined at 0, at 1/4, and at 1/2, but there is a jump of 1 unit at x equals 0, and that will account for the rest of my probability. This will give me 1/4 of the probability, this will give me half the probability, so this will give me a 1/4 or 1/2, that's 3/4, and this jump over here will give me the other 1/4 of the probability. So let's compute the expected value of this. So the expected value of x will be 1/4, that's the probability that x equals 0, times the value that the function takes on, 0, plus I will integrate 1 between 0 and 1/4. And then I will integrate between 1/2 and 1, x dx. So this first term, this jump, will give me nothing. Then I'll have x squared over 2 from 0 to 1/4, plus x squared over 2 from 1 to 1/2. So if we simplify this, I'll have 1 over 16, so I'll have a 1 over 32 from the first term over here. Then I'll have a plus 1/2. And then I'm going to have a minus 1/8. So if we put this all into 32s, this is 16 over 32. And this is going to be 4 over 32. So I have 16 minus 4 plus 1, so that's going to be 13 over 32 is my mean. Now let's compute our variance. So to find the variance, it'll be the expected value of x squared minus the expected value of x quantity squared. So now we already know what this value is over here. It'll be 13 over 32 quantity squared. All that remains to do is find the expected value of x squared. So the expected value of x squared will be 0 squared times the probability that x is equal to 0, which again will give me 0, plus the integral from 0 to 1/4 of x squared dx, plus the integral from 1/2 to 1 of x squared dx. So this will give us an x cubed over 3 from 1/4 to 0, plus x cubed over 3 from 1/2 to 1. And from this, we also need to subtract, that's just the expected value of x part. From this, we'll need to subtract off minus 13 over 32 quantity squared. And that will go over here as well. So let's continue this calculation. So I'll have 1 over, so I'll have a 1/4 cubed. 1/4 cubed is 1 over 64. So I'll have a 1 over 4 cubed times 3 from this first term, minus 0. Then I'll have a plus 1/3. And if I plug in a half, I'll have minus 1 over 3 times 8. So altogether that will be this term over here. And then from this I will subtract off, that's my expected value of x squared, minus 13 over 32 quantity squared. And this expression over here after simplification or plugging into a calculator will be the variance of the random variable x. Thank you very much.